Buddy. Thank you. This is a very timely topic, I think, for many of us, building teams with graduate student research facilitators. It's a way to extend our ability to impact research at our different institutions. What we've done for the topic today is we have two research computing professionals who are going to speak, and then two graduate students who are going to tell us about their experience. We're going to start with the Northwestern team. So that'll be Colby Witherup Wood, who's a data scientist in research computing. And then following Colby, we'll have Dan Turner, who's a PhD student in the Department of Linguistics here. After Dan speaks, we're going to move over to UC Berkeley. And Amy Neisser, who is the consulting and outreach lead for Research IT, will start. And then we'll move to Heather Amato, who's a PhD candidate in environmental health sciences. We really want to invite questions. Questions go to the call doc or also to the chat. The intention that we have is that each of our presenters will present about 10 minutes and then we'll dive into some conversation. But they can also answer questions that you have in the chat or the call document while this call is underway. So go ahead, Colby, take it away.
Hi, everyone. Let me share my screen. So I am Colby Witherup Wood. Hopefully everyone can hear me okay. I am a data scientist. I work with Jana on the Research Computing Services team here in Northwestern IT. Jana is on what we call our HPC side of the team, and I am on the data services side. So first, I just want to thank Jana and Amy for inviting me to be here today. I know that we would not be able to provide the services that we do without our student employees, and so it's a really important topic for us. And I am joined today by Dan Turner, who is one of our graduate student data science research consultants. Originally, I was going to talk for a little bit about our services and what we do with grad students, and then have him talk about a project he's working on. But Dan is actually on the road right now, and so he is joining us from somewhere between Minnesota and LA. He may be having some issues staying on the call, so we're going to go with it. I'm just going to ask him to chime in when he can. Just a little bit about Dan. As Jana said, he is starting his fifth year he's going to be starting his fifth year as a PhD candidate here in the linguistics department, and he's starting his third year of working with us in research computing services. Dan, are you there? Are you able to say hi?
Can you hear me?
Yep, we can hear you.
Excellent. Yeah, when we hit 100 participants in the Zoom room, my internet completely gave out. Sorry.
It's all right. We'll hopefully you'll be able to chime in when you can.
Yeah. Okay.
So Jana said we have 20 minutes total between me and Dan, and of course I have way more than that in materials. So if I'm talking fast, I apologize. Our data services team, I work with Christina Maimon, and she's our data services lead on our team. We are the only two full-time staff members. We have a staff member who currently is with us 1/6 of the time, who is a data visualization specialist. We have 3 graduate assistants, which are PhD students who earn their stipend in exchange for working for us. So they don't have to TA or RA in their home department. These are funded by what at Northwestern is called the graduate school. They work for us about 10 hours a week. Of course, in reality, some weeks it's a lot more. For example, if they're preparing a workshop, other weeks it is less. We are about to start our third year of having GAs on our team. We also have 3 to 4 hourly graduate student consultants on our team. So these are students who get paid hourly to work for us. They get to decide when they're available and how much they want to work. And we are starting on our 4th year of having hourly graduate student consultants. And then we're starting our very first year. So this summer actually having undergraduate consultants, and we brought in undergraduates for 2 reasons. One is because they have the skills. So undergrads now, we have so many who have just as many technical skills as some of our graduate students. The second reason is that undergrads participate in our services as researchers in very different ways than our graduate students, postdocs, faculty, and staff. That's something that we've noticed here at Northwestern. And so using these undergraduate consultants as a way to reach out to undergraduates who need help with their research. So here's a quick overview of what data services which data services we provide. And this is data from last year, which of course was a very strange year for everyone. And I've put underneath who provides these services on our team, students or staff, or both. And we do a lot of one-on-one consultations, which can be simple code troubleshooting questions or more complicated data science questions. And then we take on some faculty projects when we have capacity. And this is something that we're kind of focusing on today, at least I am in this presentation, is using graduate students to assist faculty. And we do treat those projects a little bit differently than we treat our other consultations. So the other consultations with grad students, undergrads, postdocs, and staff will often help them get started on code. We'll give advice. We don't write code and complete the project ourselves for them, but for faculty, we sometimes do, again, when we have capacity. We also teach a lot of workshops that our grad students work on with us. We have a new program where we have what we call Bring Your Own Data working groups, where researchers check in once a week with a small group on a data science project, which has been going really well. And then when we're on campus, we have drop-in hours. And the drop-in hours are where we get most of our undergrads. So they come to drop-in hours. For some reason, they don't like to fill out the form online asking for help. So we try to target them with these drop-in hours. Okay, so first I'm going to talk a little bit about hiring and recruitment of graduate students. There's kind of your normal ways. I will say one way that has been successful for me is recruiting from workshop participants, or we have these working groups. So if I see a talented grad student in one of these groups who is good at helping out their peers and giving advice, then I will invite them to apply for our positions. So that's a great way that we've found. Graduate students, their schedules are always changing. So you'll have someone commit for a year, but then they get a really prestigious internship or fellowship for a quarter, or there's a class they really want to teach. And so you'll always want to try to maintain positive relationships with the students you don't hire, because you may need to pull those talented students in for a quarter at a time. So it's just a little bit of advice if you're getting started with hiring students. And then I also really enjoy having these multiple levels of commitment. So having these GA positions and then also having hourly positions, because people can stay working for us. So we still have these experienced consultants on our team, even if they need to transition to a different position. So that's another thing that has really been good for our recruitment. And then for hiring, obviously you may think about technical skills. I will say for our last hiring round, I had 2 GA positions that I was hiring for next year. We got 30 applicants for those positions, and 25 of them were excellent in terms of their technical skills and abilities. So then it really has made it possible to focus on their consulting skills. Obviously, I only want to hire people who I can really trust to go into a meeting with anyone and treat that person with respect and patience. And then the big thing is balance. So building a team is all about being able to help people with more. For us, it's all about being able to help people with a larger diversity of questions. So you don't want to have all Python coders on your team. You really want to try to represent lots of languages, lots of different skills that people, machine learning, text analysis, image analysis, trying to have as broad having as broad of skill set as we possibly can. And then also representing different departments across the university. And so that's a really important thing as well, because occasionally there is kind of a domain specific question that comes up. And so it's good to have people representing multiple departments. So then I'm going to briefly talk about faculty projects. So we do, as I said, we treat these a little bit different. And I'm specifically talking about having students work on projects with faculty. We try to get all of our GAs, at least one faculty project per year to work on. I look for longer projects that are really product driven. So something that they can put on their CV or point to in their portfolio. So whether that's a paper with authorship or if there's some sort of visualization product that they can point to. And I don't have time to talk about all of these. We do try to prioritize faculty who maybe don't have funds to hire someone. So it tends to be certain areas of the university where they don't have as much grant funding to hire RAs or postdocs. So when we can, or when there's a conflict, we do try to prioritize that. We always give student choice. So I'll present a project to a student and they can say yes or no. And then of course, we want to get projects where we know that the faculty member is going to treat the student well, not try to take advantage of their time. If I do see any red flags when I meet with a faculty member, Christina or I will take that project on ourselves, right? We'll keep that as a staff project rather than having one of our students work on it. It doesn't happen very often, I'll say that, but just in case. Here are some examples of some of our projects. And I'm going to bring Dan in here because I have 2 examples of projects that he has worked on. And the first is building a Shiny app. So I have a screenshot. This is a project that it's about racial disparities in police arrests. The paper came out during 2020, and the PI on this paper, Beth Redbird, she knew that this was going to be a paper that was going to get some media attention, and she wanted to have an interactive Shiny app. So Dan, do you want to talk a little bit about what you did on this project?
Yeah, on the Shiny app, we were taking a really complicated statistical model and casting it over a pretty complicated interactive map made with Leaflet. So it was all running on Shiny with R on a Shiny apps server. So it wasn't like on our Northwestern server, but we did all of the programming and all of the data preparation to make sure that the data would be securely hosted on this outside server and serve up the data, you know, according to some filtering that the user can set up. So we have like a nice user interface. We have some tabs where you can click between like a fact page, a contact page, a page that links to the data in a repository. And so we kind of made a one-stop shop for all of the data on that project so that people can go in and explore it on their own in a lot of different ways.
Yeah, and I'll say that one of the biggest challenges I saw of this project was also not only were they doing this coding, you know, complicated coding of this Shiny app, but this is also a good example of data that can be misinterpreted by people. So they had to be very clear that only certain comparisons could be made in the data with the app, and that other comparisons couldn't be made, ones that are not statistically valid. And so, Dan, I think that was also a cool part for me to see.
Yeah, exactly. The specific concern was it allowed you, in theory, to compare differences in police bias against different racial groups across like any given county in the United States. But because of you know, the problems with sampling, those are not always comparable from county to county. And so there was actually some functionality that we had to limit in order to make sure that people weren't misinterpreting the results. Yeah.
So this is an example of one of the faculty projects that Dan worked on. The second one is still wrapping up. This one is maybe a little less straightforward. This is a project where researchers at our medical school are using electronic medical health records to build family trees to infer relationships, so that researchers can then use that for study, for example, to look at intergenerational patterns of disease. And so this was kind of this is kind of creating a software program in a way. Dan, he did this in Python and kind of brought, you know, really, I think was a challenge for your skills, and you learned a lot on this. And he created, there was already some existing code that he adapted into Python and that he added new functionality to, and that he also optimized to run faster on servers. So Dan, do you want to talk a little bit about this?
Yeah, the original code was set up to run over a database of emergency contacts and to infer how people were related to each other in relationships that weren't given when they were filling out their emergency contact info. And so like if you and another family member share the same emergency contact. This software, assuming that all three of you are in the system, would be able to infer that you are all part of the same family unit. And then that would be used later for like preventative medicine research to see, what kind of hereditary medical issues might come up. And the script that was running incorporated a couple loops and a couple other like slow types of processes. And what we needed to do was make sure that its output was clean, and we needed to make sure that it could repair relationships that were incorrect. So for example, the original script would sometimes flip the relationship between a child and a parent. And it didn't include any age information in the original script. And so what we did is we made sure that the script could incorporate some basic demographic information to repair those relationships to eventually have a much better product at the end. And the product here is a collection of family trees for the whole database. And one of the ways that we did that was incorporating a repair stage and then transforming the script into something that was recursive instead of something that would just run from beginning to end. And so it's designed so it can continuously repair and reinfer new relationships over the data as it gets new data. And so you end up finding a lot more hidden relationships that you can use to make inferences.
Yeah, and so a lot of complicated coding on this one that Dan was able to help them out with on a project that they had been having postdocs try to work this code, but then when they left, it was just stalling. The project was stalling out. And this was another interesting one because this was a faculty project where our primary point of contact was actually the faculty member's kind of research lab manager. And the faculty member would kind of just pop in to certain meetings, but wasn't our primary contact. So it's an interesting project. So I know we don't have a lot of time here. Before a faculty project, I just want to mention a few things, and I will put a link to these slides in the document. I always, when we're working with the faculty project member, a staff member would meet with the faculty member alone to get a sense of them and of the project, and also to give technical steps on exactly what actually has to get done for the project. Then I write up a very clear document that has this to-do list for the student, proposed deadline, and notes about how the work can and cannot be expanded, because that's always the big concern, because we know obviously things are going to change. So just being clear about it. Another thing that is my role as a staff member is during the project, if I do see these areas where I feel like the project is ballooning, I will speak up and specify what is within our scope and what would need to be kind of reworked or what can be talked about later to see if the student is still available to help on. And part of this is not just about me looking out for the student, but also modeling language and modeling this skill of speaking up about negotiating the size of a project. And then my last point here is just that, like any employee, every grad student you work with is going to be unique. And so it's not just a set of skills that you have to have when you're supervising them. They're not the same. They're all different. Some of them are going to need more technical advice. Some are going to need help with deadlines or with communication. And so every student is unique, just like every employee. And then that's something definitely to keep in mind. And if we have time, I don't know, Jana, do I have a few minutes?
You have maybe a minute.
A minute. Dan, I'm just going to ask you one question I had some list of questions here. And the question I'll ask is, what differences, if any, do you see between when you're consulting with a grad student or a postdoc versus consulting with a faculty member?
Yeah, there are a lot of differences. I think just to make some generalizations, generally faculty are a little bit more narrow in their learning goals for what they're trying to accomplish with the data science. Whereas I find that working with grad students, a lot of times there's like an exploratory element, and then there's a more hypothesis confirming element, and they kind of work hand in hand. And so that's always something that we look out for in terms of ballooning learning goals, just to make things, concise and actionable, and make sure that we set our expectations really clearly in the beginning.
Great, thank you so much, Dan. And again, thank you, Janet and Amy. I know there's a lot of questions, so if we have time, we'll get to those and I'll try to answer some of those in the chat.
Thank you, Colby. And yeah, if you could go to the call document on the bottom, there's some unanswered questions if you want to tackle those. And thanks also to Christina Maimon, who has been answering those questions throughout this talk. All right, so now we're going to move on to UC Berkeley. We're going to start with Amy Neisser.
Hello, everyone. Just going to share my screen really quickly here. Awesome. It's fantastic to be here, and I'm really pleased to be here with my colleague, Heather Amato, who will be speaking in a few minutes. And it was so interesting to hear from you, Colby and Dan, about the similarities and differences between our programs. So I certainly learned a lot, so thank you very much. I'm just going to start with a really quick intro. My name is Amy. I'm the Consulting and Outreach Lead in Research IT at UC Berkeley. Here's just a little bit about myself. And yeah, so I manage the consulting program, which I'll talk about a little bit more, as well as our outreach efforts. And that's outreach to campus, to the other UC campuses, as well as to national efforts like CaRCC and other organizations and efforts. So the Research IT program at UC Berkeley, we provide research data and computing technologies, consulting, and community for the campus. And our goal is really to advance research through IT innovation. We see ourselves as advocates for researchers' needs and perspectives. We help them navigate the many options and confusing things on campus. And what I really want to say here is that our graduate students on our team are absolutely essential to achieving this mission. And our computing and our data programs used to be separate, but we've brought them together, as you can see here on this continuum. And our domain consultants really help us bring these two areas together to provide holistic services to our researchers. One thing I was thinking about while I was hearing you speak, Colby and Dan, is that we don't distinguish as much between faculty and graduate students, and we don't really treat those consultations quite as differently. We really talk about researchers, and so that could be a postdoc, that could be a grad student, that could be a faculty, and so we kind of put them all together and don't make as much distinction between those. And so I found that very, very fascinating. So as I mentioned, we've brought data and computation together, which has been really great for us. Our consultants are the first point of contact for researchers. So the goal of them is to learn about what the needs are and to match those folks to appropriate services and resources. And we have an incredibly diverse team. And I would say that that is really our success is in our diversity. And so our team is made up of research IT staff like myself. We also work really closely with the Lawrence Berkeley National Laboratory staff. They help us run our HPC cluster, and they are also on our consulting team. We have librarians on our team. We have an adjunct professor who's in statistics, which is really nice, and we buy out a small portion of his time. We have our graduate student domain consultants, which I'll be speaking about more. And we too have been working with undergrads a bit more lately. So that was really cool to hear about that, Colby. We have had a history of working with undergrads as our interns for our research computing program. So they're the ones that'll go into the data center and run the wires and things like that. But we have been working with other partners on campus to launch this program called the Data Peer Consultants. And it's about undergrads consulting with other undergrads about data topics specifically. So I'd love to get together with you, Colby, and sesh about that a little bit and learn more about that. Oops, excuse me, I'm jumping around here. So we, together, the data and computing folks, we have shared office hours. So if somebody comes in with a computing question, we have the data folks there listening and saying like, oh, hey, well, have you backed up your data? And do you need some help with other aspects of your data? We come together at a shared consulting meeting. We have a shared consulting handbook, which I have a link to, and I will drop that in the chat when I'm done speaking. We do all of our metrics together as well, and we also cross-train each other as well as come together sometimes and provide training for researchers as well if it has a data and a computing aspect to it. Just a couple quick stats to give you an idea of what we're working on. We do like around 200, a little more than 200 consultations a year to over 100 different campus units. So we're not just working with the high energy physicists, we're working with the social scientists and the digital humanists as well. That does not include tickets. I saw a question fly by in the chat about answering tickets. We do have our consultants, which includes our grad students, answering those HPC help tickets. How do I log into the cluster, things like that. And we do about 1,100 of those a year in addition to those 200 consultations. So quite a few. That's fun. Somebody's drawing on the screen. I like it. We do maybe 15 training engagements per year, but that can fluctuate quite a bit. Yeah. So let's talk about the grad students specifically. So their mission is to help extend the reach and impact of campus and national data services and research computing infrastructure, again, to support research. The graduate students are completely essential because they themselves are researchers. So I'm a staff person, but the graduate students are getting their PhDs in these areas. And so they really have a very in-depth look at what it looks like and what researchers really need in their specific domains. So we really like to hire graduate students in different disciplines. I'm really glad Heather is here to speak today because the School of Public Health, I would say, is probably our biggest customer. And we really needed somebody who was kind of on the inside there to help us understand why that is, what are their needs, what's going on in public health. And Heather has been absolutely essential for doing that. So these bullet points are a few things that our graduate students do. So like I mentioned, they help leverage these data and computing resources. They help provide education and outreach. Heather will talk a bit more about the outreach angle. And they also help document solutions. So we have a really robust documentation site that the graduate students and others contribute to, and that really, really, really helps our researchers quite a bit. So a little bit on how we get these amazing folks. I also saw a question in chat about the job description, and I'll drop the link to ours in the chat as well. I recently updated it, and it was really more about highlighting what the benefits of being a domain consultant are. I think the first line is get paid to develop your skills in research and compute. And so I'm trying to make it attractive, not just like, oh, come work for us and answer tickets, but really, understanding what these folks' goals are, matching them to work that will advance their careers, and getting paid while doing it. Sounds pretty good to me. I also did a fair amount of targeted outreach to campus groups, especially those that represent underrepresented folks. So one example is the graduate women engineers. There was a Black science group on campus that I've been working with quite a bit, the open computing facility, things like that. So rather than just posting it on a job board, really going out and saying, we want folks of color, we want women, and trying to recruit that way. And Colby, we too have been doing targeted outreach to individuals who have used our services. And actually that's how we got Heather, who you'll be hearing from. So, these are folks that we know are interested in these areas, are doing this work. We've interacted with them. We're really impressed by them. And then we go out and ask them if they want to work for us as well. The interesting bit here is sometimes there can be a bit of a negotiation with the student and their advisor. And I have found in some cases that we really need to pitch this and make it attractive to the advisor and make sure that they understand that by having their students work with us, their students are learning and developing, and they can bring those skills back to the lab, and then it benefits the lab instead of us just sucking away, 20% of one of their graduate students' time. Of course, that varies based on the faculty member. Excuse me, I'm so sorry. But sometimes that can be the case. As far as our onboarding, what I would say one of the perks of being a grad student on our team is they have access to our staff. And so we usually tell students that it's about a year of onboarding. We still, we have them go out and participate in consultations, but we give them about a year or so to, co-consult with other consultants, to meet with the other graduate students, to learn about their areas of expertise. So we really consider the onboarding kind of a lengthy learning process. And what I will say about the funding is, this is the deal of the century. I mean, for the money that we are paying and versus the value add, it is just crazy because we would not be able to extend our services the way that we do out to campus. We're actually a very small team at Berkeley. Our kind of secret sauce is that we buy out small portions of a lot of people's time, like we do with the national laboratory that I mentioned, or that adjunct faculty member. So kind of buying out small pieces of folks' time, as well as those graduate students. So if we get, a handful of grad students at 10 hours a week, we now have a very, very big team. So I would say if you're looking to do this, start with one, start with two, and then document their impact and tell your success story. And then you will be able to hire more folks. And with that, let's hear from Heather herself. Heather, I don't think I can hear you. No, so sorry. We didn't test this before.
Okay, can you hear me now?
Yeah, perfect. Thank you.
Oh, great. Okay, I think it was a double monitor issue. Okay. Thanks so much, Amy, and thanks everyone for having me. As Amy said, my name is Heather and I am a domain consultant with Research IT. I'm a third year PhD candidate now in environmental health sciences in the School of Public Health. My background's in psychology, global health, environmental health, public health in general. So I don't have a background in data science. So Amy was mentioning the year-long onboarding process, and I've been with Research IT for just over a year now, and I finally feel like I've sort of found my space and am able to really contribute now. So, but it's taken some time and lots of training, which I'll talk about a little bit. But so before I started my PhD, just a little bit more background, I was working as a data analyst for a nonprofit public health and environmental justice organization, sort of a partnership between the Public Health Institute and the California Department of Public Health. And my current training and general background, again, are just in public health research and practice, epidemiology, biostatistics, exposure assessment, a little bit of bioinformatics. That's more of current and future training now. I have a lot of experience with human subjects, data collection, data management, and analysis. And I've worked on topics ranging from real-time community air monitoring to looking at emergency department visits among sickle cell patients, and now more focused on infectious disease transmission. So I've really worked on a range of topics and covered a range of types of data and different approaches to data management in lots of different work settings. So I think that I've gained a lot of experience just through that prior to even starting my position as a graduate student and a domain consultant. And I think, it's kind of interesting the way that I started out as a consultant. I was, when I started my PhD, I didn't even know that I was going to really go into the data heavy computing side of things. I have work in microbiology, so I was considering maybe doing wet lab work more so. And a couple things just sort of happened and came together that worked out to sort of funnel me into this path, which I'm really grateful for now. But I ended up getting an NIH biomedical big data training grant for my first year, and that sort of funneled me into more statistics and computing focused data science classes. And then with my background in data management and coming on as a grad student with a relatively new faculty member who didn't have any other staff or PhD students, I was sort of taking on the responsibility of doing data management for a very large NIH R01 study. So I actually had a consulting meeting with one of the other research data management consultants, and I was asking him 1,000,001 questions. I think we sat down for a total of like 4 hours. And I think because I was so interested in getting everything right and figuring it out, then my now coworker, Rick, he, kind of push the group to maybe talk to me about working with them instead and really diving deeper into training and learning more about research data management. So that's sort of how I started. And yeah, I think the first year was a lot of just trainings, both internally. There are a lot of trainings that Research IT has recorded and conducted at Berkeley. So I was able to sift through those and learn a lot from our online like YouTube videos and that. So I think that was a really great place to start as a consultant. And then talking to individual consultants who had been working there for a little while and just understanding what the experience was through co-consults. And then also external training and mentorship too were really important. So Amy and Research IT are really great at supporting professional development in this area. So I was able to take a sort of HPC boot camp through Exceed I think it was last summer. And I also got some mentorship through the Women in HPC program. So all of those things combined and being somebody who's not in data science and HPC, in terms of my research field, it's been great having the mentorship from Amy and others at Research IT who know how to navigate all of that and can point me in the right direction for how to learn different things and identify trainings that might be relevant to both me as a consultant, but also as a researcher. So now that my research is going more into the bioinformatics direction, and we also see a need from our researchers who are coming to request help, that bioinformatics is a really big area that we need to sort of up our game in a little bit. So I'm going to be focusing my training more on bioinformatics in the future. But yeah, I guess, next slide. Thanks, Amy. So as I mentioned, when I first started, I was just kind of generally getting the hang of things, doing a lot of general consultations. And then this year, Amy and I sort of recognized that my skills and background were really aligned with one of our specific areas and services that we offer, which is secure data management and computing, or SRDC. So our SRDC platform involves custom virtual machines, HPC, and data storage for secure data, so highly sensitive data. So part of my role, in addition to just consulting around this, but one of the main projects that I've been working on is conducting targeted outreach to faculty, staff, and students in the School of Public Health. And I think being a student who, I've been taking classes in the past couple of years, so I have a lot of close connections with faculty members who, have been seeing my face all the time in class and that sort of thing. So if I email a professor that I've just had 2 classes with in the last year, and asked them about, what kind of software would you need if you were to access a secure virtual machine for computing. I think that maybe, no offense to Amy and other research IT folks, but they might be more likely to respond to my emails and give me a little bit more detail and more of their time than if it were just sort of a general, email blast to everybody. So I think that was really, kind of an advantage that I had in accessing folks, picking their brains. And so I did email maybe I think I got responses from about 20 different faculty, staff, and students, so not a huge sample size, but I did get feedback from all sorts of divisions in the School of Public Health. So epidemiology, biostatistics, infectious diseases, health policy management, environmental health, community health sciences. And so what I noticed when I put all this together, and this is the chart on the right, when I was asking specifically about software needs for secure virtual machines, we could sort of group the software into these 3 categories rather than just by division, but it was more by the types of analyses that they were doing. So we have our folks who do biostatistics and mathematical modeling. We have our general epidemiology folks who cover all sorts of divisions and topics. And then we have our molecular epidemiology folks who clearly, based on both their core and supplemental software needs, have a much greater diversity and depth of software needs. So, but using this, we can really see which softwares we need to be prioritizing when we're building out our virtual machines. And yeah, so this work sort of informed the next step that I was involved in, which was developing test code so that when researchers are accessing their virtual machines for the first time, before they get their data, or maybe before their personalized custom virtual machine is ready, we have a test environment that they can go in and test out the performance using these scripts and data analyses that are ready to go in the virtual machine for them, so they can get a feel for the performance and request more specific more specific software packages, or customize the performance a little bit if they need more memory or more processing power and whatnot. So I developed test code in Stata and R, and I'm working on Python, which is not a language that I'm familiar with. So I work in R primarily. So I had to learn a little bit of Stata. I'm learning Python now. So these are all skills that I'm building as I'm working on this project. And I pulled a bunch of publicly available data sets and sort of processed them and worked on those a little bit to make them ready to go for these quick analysis scripts. So I'm putting together a little one pager with just some directions on what folks should be doing for that. And then finally, I'm always involved in the actual consulting aspect. So in the process of rolling out the virtual machines and having researchers come on and begin their work in the secure virtual machines, we have really weekly or bi-weekly meetings with researchers to make sure that everything's going smoothly, that we have a really thorough understanding of the data flow process. So we have, I've put together diagrams showing data ingress and egress to really understand exactly where the data is going and how it's getting there. And one particular example that I'll mention briefly is just a couple of researchers, so a faculty member and a research staff member who I know very well in public health. I've been working with them a lot on this specific project with an SRDC virtual machine. And just having that relationship prior to working on this consultation with them, I think it really expedited the process. So normally the process of onboarding, getting the virtual machine ready to go, signing the necessary paperwork and secure data agreements, that process can take about a month. But with these researchers, it took maybe 2 weeks tops. It was super speedy. And so I think that was also a really big advantage. The faculty member knew me well and was just like ready to go, ready to sign things, work on the data, and just move forward. So yeah, I think I'll stop there. So yeah, thank you all very much and happy to answer questions with Amy.
Thank you, Heather. I have a quick question. So as somebody who's done this work, what are some of the challenges that you found that maybe people in research computing might not be aware of?
Yeah, some of the challenges, excuse me, for me have been, I think, navigating, well, I don't know if this is something that you all might not be aware of, but I think it's just navigating as somebody who is new to the area of data computing and being in a position of authority sort of as a consultant when I'm still very much learning has been a little bit difficult at times. But at the same time, you know, I've had consultants with a lot of graduate students who are extremely appreciative that I'm also a graduate student who's learning you know, how to use HPC systems, for example, and they feel a little bit less intimidated when they're coming to ask for help. But I think, yeah, just generally learning about HPC systems, that's been a big challenge for me since it's really not my background. So yeah, I'm trying to continue to go to all the trainings and everything that I can.
Got it. Thank you, Heather. I just want to remind our speakers, there's the questions from the chat have been captured in the call document. So if you could take some time to provide some answers in there. I think we have time for a question. Something that's come up rather frequently is around funding. Has that been a challenge to secure funding to hire graduate students? I'll send it to Amy.
Amy first. So, you know, luckily, when I took this position, the domain consultant program had already been established. And actually, I think I saw Patrick Schmitz on the call, who was essential to that. So I was kind of handed this amazing program, but I've been able to grow it. And that was really through demonstrating the impact. So we write a lot of news articles showing that, you know, like, here's how these graduate students helped with research. We keep a lot of metrics, like I mentioned, demonstrating that. So it was easy for me to say, like, look, we have this small pool and I need more. And so in that way, it was easier for me. But I would love to hear from Colby on this.
Yeah, so I mean, this is more a question for Christina if she's still on here. I wasn't that involved with having to secure the funding. We get our graduates, our GAs are funded through the graduate school. So they have, Northwestern has guaranteed stipends for all of the students. I know that's not the case at all universities. So we're very lucky. Our grad students are very lucky here at Northwestern. And so the graduate school has a certain number of those that it gives out to different programs that it pays for. So we have been lucky to get 3. We have asked for more. We didn't get those this year. And then the hourly students get paid through IT. So we have to get those positions approved every year as well. So there's a little bit of, you know, there could be some changes in that depending on how the university is doing and depending on how they want to spend their funds. So.
Well, thank you so much, Colby and Amy and Heather. And of course, thank you to Dan too, who is unable to be on the call at this point. Thanks everyone for joining. I really appreciated the questions. I'm sorry we don't have more time right now to dig into it in person, but check out the call doc because we have a lot of answers there. So again, just to wrap it up, thanks Colby Witherup Wood and Dan Turner from Northwestern and Amy Neisser and Heather Amato from UC Berkeley. Really appreciated your presence here today with our conversation. Our next call will be on August 12th. Please fill out the fall call topics survey. There's a link in the chat. There's also a link on the call document. Perk 21's coming up. If you register, then we might all be there together. That'd be kind of fun. And I just want to thank everybody who worked on the call. So we've got Justin, Gladys, Christina, Wirwan, Martin, Annalie, Amy, Katya, Bob, and I'm Jana Nugent. Thanks for joining us today, everybody.
Just a quick thing. We are actually making a slight change on the August call. I haven't announced it yet, but we are planning just to give everybody a break after PERC. We're not going to have an August call. We're going to have a plenary all-track call. Sorry, Jana. Didn't get a chance to get this out. An all-track call is in the works for security across research, computing, and data. So stay tuned. It will be mid-month, I think the same time as the Emergency Centers call. So we invite you all to join, and thank you, Jana, and all the speakers. So.
Yep. Thanks, everybody.